So this is our weekly workshop. My name is David Raymond. I'm the director of the Virginia Cyber Range and the US Cyber Range. And we are continuing along the vein of capture the flag activities, right? So last week, Tom Weeks filled in and talked about general CTF challenge solving tips, right? So he gave some sort of general approaches to solving any CTF challenge. And if you haven't seen that one before, you ought to go back and refer to it. It's got some good tips related to things like the challenge name and the point levels and all that kind of stuff. He also talked about having a Linux command line being useful for a lot of CTF challenges, and we'll see a little bit of that today. Then this week we're going to talk about introductory cryptography challenges. So I'm just going to give an intro to crypto challenges in general. And I'm going to focus primarily on sort of the lower end of this crypto challenges, right? This will be introductory level challenges. So I'm going to do walkthroughs for some low point value challenges. I didn't quite get my slide fixed. I got a typo there. Some low point value challenges. And then later on, we're going to come back to cryptography challenges and maybe talk about some more complicated ones. But today, this is really going to be introductory. So we'll focus on the lower end of the point values. And then, Maureen, we got more people coming in the waiting room if you want to jump on it. Then next week, we're going to talk about networking challenges. So I'll do the same thing. I'll do a little bit of an introduction of networking challenges in general, and then I will we'll walk through some relatively low point value networking challenges. There's a CTF setup that you may have signed into last week. If you did, you can just log right back into it. Here's the URL, vacr.io/weekly workshop. This CTF is open for public registration. So anybody can click on this, go to this link and just register yourself and start playing the CTF. I'm going to warn you, as I had put on this slide for last week, the challenges are going to move around a little bit, right? This isn't a competition that somebody's going to win. This is a CTF that we're just using to kind of practice a little bit. And so today I moved some challenges around and added some more cryptography challenges so that you could so I could have some specific things to refer to, and I'm going to solve a handful depending on the time that we have today. So here's the workshop CTF. Get a screenshot of this if you need the URL. Pretty straightforward, vacr.io/weekly workshop, all one word. Okay, and so here we go with cryptography challenges. And if you've been to a CTF workshop that I've done before, you've probably seen most of this. I do this workshop in various venues, and I do it. We host an annual cybersecurity education conference in Virginia, and I usually talk about CTF stuff during that conference. So if you've been to one of those sessions before, this portion of it is not going to change very much, but I am going to solve some different challenges that you may not have seen before. Again, depending on how many of our CTFs you've done. So cryptography challenges. Generally, what you're going to see is you're going to see some sort of encoded message and some hint as to the encoding, right? So you have to take some encoded blob or some encrypted blob, and you have to turn it back into the plain text, and then you have to enter that plain text to get the flag. So the approach to solving is at least for the entry level challenges, it's generally pretty darn straightforward. Turns out that many challenges that you see in the cryptography category aren't even encryption. You'll often see challenges that are actually just encodings. And an example of an encoding is ASCII encoding, right? So there's an encoding scheme that helps us to translate from numerical values to the alphabet. We know that the way computers store data is in binary, and that binary is used to represent numbers, right? Binary is used to represent numbers. So you have to have a way to turn numbers into letters so that you can have text on the screen like I have here. And one encoding method for that is called ASCII. That's an acronym, and I'm not going to remember what it stands for, so I'm not going to try to spell it out. But ASCII, more often these days we use Unicode because Unicode has a larger it's a larger binary value, so that means we can encode many more characters. And the original ASCII table was really focused around the English alphabet, and so now with Unicode we can encode things like Chinese characters. We can encode various alphabets for different countries who have different alphabets. Sometimes see base 64 encoding in cryptography challenges. Base 64 is a tool that's used to convert binary data into a larger subset of encoded values that we can easily transmit over the internet, right? Some using some transmission techniques through the internet, like things like old technologies like Telnet. It was not straightforward to send a large binary file over Telnet, which was a software that was really designed for text communication between computers. But with base 64 and base 32 encoding, you can take these binary files and you can encode them in a way that's easily transmitted over the internet, and then you decode them on the far side. In fact, base 64 is often used to encode web pages that are sent, images in web pages that are sent between web servers and web clients. So it's a widely used encoding technique. The reason that we see these kinds of encoding techniques in CTFs is because we're trying to teach students about things related to cybersecurity and computer science. And these are encoding techniques that are used in various contexts. And if a student is going to be doing something like digital forensics, then they need to be able to recognize an ASCII string, because they may need to convert that back into the characters that it's representing. Same with base 64 encoded data, right? That's often used to transmit data over the internet. If a student if a student has graduated and gone on to be a cybersecurity analyst, they need to be able to recognize base 64 encoded data so that they know how to convert it back into whatever it was to start with. What I've done in this CTF that we have for the workshops is I've taken all those encoding types of challenges and I've removed them from the cryptography category, and I've moved them into the reconnaissance category. So we're going to see some of those later on, and you'll see how to recognize things like ASCII and base 64 and UUE encoding and et cetera. Today, we're going to focus really on ciphers and true cryptography. So my next big bullet here, my next major bullet, the first ciphers that we're going to encounter today are simple monoalphabetic ciphers, right? So we're going to take things like rotation ciphers, right? The most simple form of a monoalphabetic cipher is simply rotating the alphabet. So we take, we have the alphabet A through Z, and then we take A through Z again underneath that, and then we rotate it by some number of characters, and then you transpose, or you don't transpose, you just take the corresponding character in the rotated alphabet to make your cipher text. Obviously, that's a very simple cipher to reverse, but depending on the application, if you only need a message to be secret for a very short period of time, and especially in a situation where a lot of people can't even read or write, like maybe was the case back in Caesar's time, then something like a rotation cipher was sufficient for battlefield communications. Nowadays, it probably wouldn't work very well, but in those days, it might have been useful. So the Caesar cipher or rotation cipher, you also hear it referred to as a shift cipher. Those are all these just very simple shifts of the alphabet. The next one here is a substitution cipher, monoalphabetic substitution cipher. I should have monoalphabetic there at the beginning. This is a cipher where you're still replacing one for one characters in the alphabet, but instead of shifting the alphabet, you're scrambling the alphabet. And so the problem is a little bit more complicated. Now we need to use different, more complicated techniques. You're not just rotating the alphabet. You have to do other things in order to turn that ciphertext back into clear text. Now, these monoalphabetic ciphers generally can be easily solved without the key, especially if you have a long message. And that's because you can do frequency analysis on these messages, right? So you can usually you have to have a longer message, but you can simply count how many times each character appears in the ciphertext. And we know, because of the frequency of characters in the English language, that characters like T and E and M and N and S, those are going to be seen a lot. And characters like X and Y and W, those are going to be seen less frequently. And then in the middle, you're going to have you have this frequency of data that's pretty straightforward. And if you have a long message and a monoalphabetic cipher, it's really easy to you can even find tools online that'll do this frequency analysis for you and turn your ciphertext back into plain text. So monoalphabetic ciphers generally solved fairly easily without too much work. Where it gets a little more challenging are in these more complicated ciphers. For example, a polyalphabetic cipher, right? So a polyalphabetic cipher is one in which you might have multiple characters that represent a single character in the ciphertext. And I've listed some of these polyalphabetic ciphers here. Things like a Vignere cipher or a Playfair cipher or a Beaufort cipher or an auto key cipher. You can look those up online. Those are all pretty common polyalphabetic ciphers. And for these ciphers, you need to have a key, right? So you can't, it's not just a matter of doing frequency analysis on the output. You have to know things like, it's helpful, obviously, to have the actual key used to encrypt the message. If you don't have the key, it's helpful to know the length of the key at least. If you know if you know that the key is 5 characters long, then you can just divide the message up into each set of into 5 different blocks, and you can do frequency analysis on each of those 5 sections and decode the message that way. So polyalphabetic cipher is a little bit more complicated. Generally, if you see this in a CTF, there's going to be some hint as to what the key is, or at least the key length. You might have this really long block of text, and you might be told that the key length is a certain length, and then with that kind of information, you can use some different techniques to try to decrypt the message. And then so polyalphabetic ciphers, that's still a substitution cipher, right? You're still substituting characters for characters in the alphabet. The next sort of class of simple ciphers is what's referred to as a transposition cipher. Some examples are listed here. So you have things like a rail fence cipher or a columnar transposition or a route cipher. And with transposition ciphers, instead of replacing characters with other characters, what you're doing is you're mixing the characters around. And so, for example, here, this image on the top of the slide here is a rail fence cipher. So it's a 3-rail fence. And if you read this up and down, here's the plain text, the United Kingdom. So it's easily read, right? But if you transmit it across, TNDG, HUIEKNDM, ETIO, now it's much more, it's not readable. It's just a sort of random listing of characters. But if you know that this is a 3-rail fence, then you could easily turn it back into the actual plain text, right? So a columnar transposition is similar, right? Here's a plain text, A Midsummer Night's Dream. Here's the key across the top, and then I would transmit these in the column order. And when it's received at the far end, if I have that key, then I can easily turn that back into the plain text. But if I don't have the key, it's much more difficult. And so, why do we look at things like substitution ciphers and transposition ciphers? You might look at this and say, well, this is not cryptography, right? This is just sort of shifting characters around or replacing characters. Well, the fact of the matter is, modern cryptography, at least modern symmetric cryptography, which you use every day, every time you go to a web page, it is based on these two basic functions, right? It's substitution and transposition. And so as students are learning more cybersecurity techniques, learning more cryptography, taking a cryptography class in college, maybe they're going to learn how these simple substitution and transposition ciphers really form the foundation of modern symmetric cryptography, and they would actually see the math behind it and how it actually works. So these are cryptography in a sense, just a more primitive form. Okay, so let's take a look at some challenges. And so I'm going to go to my CTF, and my first task is to log in. Enter button in the middle there, clicking enter to log in. And I'm going to log in as the as an admin, just in case I need to open a challenge and show you something inside the challenge. But we can solve a couple of these along the way. And I'll start with this one called Shifty. I'm in the cryptography category, and I just opened up I opened up the challenge called Shifty. It's a low point value challenge. It's 10 points. So that tells me that it's probably pretty straightforward. And here's the ciphertext. The ciphertext is it's a 3-character word, and then a longer word, and then so it's 4 words. And the name of the challenge is Shifty. So I'm going to assume that this is a shift cipher or a monoalphabetic, a Caesar cipher or rotation cipher. And so the tool I'm going to use to approach something like this, there's lots of tools online. I'm going to show you a slide here in a minute that has some of those tools on it. The tool I'm going to use is a website called decode.fr. And this website has a whole bunch of different ciphers embedded in it. So you can use this website for a bunch of different ciphers. And it's originally in French, right? It's a .fr website, but you can click the button here and get it in English, which is super helpful. You can also, there's American flag and a French flag here. So you can, if you click past that Google Translate thing here, you can click the flags here and translate between English and French. And so I'm gonna on the top left here, I can find a tool, right? So I can search for a specific type of a cipher. And so I'm gonna look for a Caesar cipher. And here it is, Caesar code, Caesar, I guess I spelled Caesar wrong, CAESAR. So if I click on that, so the way this website works is you can put in different encrypted texts. Whoops, I didn't copy my encrypted text. So I'm just going to copy this. So I paste my encrypted text, right? I just copied this right out of the CTF. And so this website lets me choose different options here, right? This is a shift cipher, so there's not a lot of different options. I can choose a French alphabet, or I can choose an English alphabet. I can choose an ASCII table. I can put in a custom alphabet. That's kind of interesting. But what I can also do is I can click on decrypt automatically, and the decrypt automatically is going to do a brute force attack on this shift cipher. And a brute force attack on a shift cipher is really easy because there's only 25 possible shifts, right? If I shift 26 times, then I'm back to the original alphabet. So I have 25 possible keys. And so over on the left side here is my brute force. It gives me all the possible options of the shifts, and it's going to rank these based on what it thinks is the most likely correct answer. It puts that at the very top. The reason it thinks this is the most likely is because it recognizes all these as English words, and it knows that I'm looking at this webpage in English. So it says the password is "please change me," right? So now I can copy that password, or I could copy that whole phrase if I wanted to. The question in the when I pull up the challenge is, what's the password? And so I know now that the password is "please change me." And if I submit that, I should get my 10 points. There we go. I earned 10 points, right? If I had pasted in the entire thing, whoops. If I pasted in the entire thing, of course I've already done this. So I'll do a test here, right? Since I'm the admin, I can test answers, and this test gives me the correct answer because I use a regular expression, right? This is a regular expression, and it's around "please change me." And we'll talk more about regular expressions later on. But the way this flag is put into the system, you can put more than the actual password in, and it'll recognize it as being correct. Okay, so that's that simple shift cipher. So here's another challenge, a little bit more challenging. It says it's called the XKCD. You might even know what the password is for this, or what the flag is for this particular challenge without even reading it, if you're familiar with XKCD. So here's the challenge. In 1857, British Admiral Sir Beaufort introduced a cipher used to encrypt the message below. His first name might be helpful in cracking this code. Okay, so I know that, you know, I know that I have this jumbled message. And if you recall the previous challenge I looked at, Shifty, it had the same sort of 4-word setup. And in that challenge, it said the password is, and then it had please change me. That was scrambled up. And if I look at this, challenge, if I look at the encrypted text, you should quickly see that, you know, the second word is password. I can assume that the second word is password. But if I look at the characters, you know, if this was a mono-alphabetic cipher, then this would be 2 S's, right? The QA would be 2 S's. And so those would be the same if this was a mono-alphabetic cipher. They're not the same. So this makes me think that this is a polyalphabetic cipher. And so I'm gonna do some Googling based on the message I have in the challenge here. So Sir Beaufort introduced a cipher. So I'm gonna say, okay, cryptography Beaufort. I spelled that wrong. Oh, how about that? There's this thing called a Beaufort cipher. And it's named after this person, Sir Francis Beaufort. Okay, well, that's helpful. And here's the second link on here is a link to decode.fr, and it's the Beaufort cipher. So that's even more helpful, right? So now I go back to my challenge, and I'm going to copy this phrase. I'm going to copy it, and I'm going to paste it in here. And oh, I'm still on my Caesar code here. Beaufort cipher. Now I need to paste this thing in. Okay, I've pasted it in, and from my Googling, I know that the key is Francis. I guess I did this on this system before. It's saving my work. The encryption key is Francis. Now, if I didn't know the key, but I knew the length of the key, then this thing could actually try to do a brute force on the length of the key. If I know maybe you know what the key is, I can put that in. You know, this system lets me put in different potential information. But the best thing here is if I know the key, I just put in the key. I click decipher, and up here I get the answer. Here the password is correct horse battery staple. So I'm going to copy that. I'm going to put it in, and I'm going to submit, and I'm going to get my answer. That's correct. Earn 15 points. Okay. 426. Let me do one more here. I'm going to do one more cryptography challenge. This one, I want to do this one because I have to go an extra step, right? There's a file that I have to download, and then I have to do something with the file that I download. So it's a little bit more involved than just copying a phrase out of the challenge and taking it to some website. It says the encryption key is the last name of the person that developed the software used to encrypt the file. Okay, encryption key is the last name of the person that developed the software used to encrypt the file. Okay, so I'm gonna click on the file here. So this is a download. So I downloaded this thing. It's called plain.txt.cpt, and it's a CPT file. So when I open that in when I try to open it in Windows, I'm on a Windows system here. Windows doesn't like that very much. But I'm going to go to my command line, and I'm here in my downloads folder. I'm using the Windows Linux subsystem for Windows. And so this is an Ubuntu terminal that I have on my Windows system, and I'm in my downloads folder. So if I do an ls, I see this file plain.txt.cpt. And if I want to figure out what that is, plain.txt.cpt, it says it's data, right? So that's not super helpful to me. So how do I solve this? Well, let's go back to my CTF. It says the encryption key is the last name of the person that developed the software used to encrypt the file. So first I need to figure out what kind of a file it is. So let's say file extension CPT. File extension CPT. Well, CPT is a graphics file format used by some versions of Corel Photo Paint. Okay, well that's probably not what I'm looking for, because right in the challenge it says that this is an encrypted file, right? It's an encrypted file, so it's not a Corel Photo Paint file. So maybe I need to Google a little bit better. I need to try harder, right? Cryptography. I'll put a cryptography on the end here. Okay, so now I get a different answer. File archive encrypted with Ccrypt, utility for encrypting and decrypting files and streams based on the Rindell cipher used as an asymmetric encryption algorithm, yada, yada, yada. So Ccrypt. So I need to use Ccrypt to decrypt this file. So I'm going to say Ccrypt. And okay, well, Ccrypt's not found. But this terminal helps me out here. It says Ccrypt is not found, but you can install it. Sudo apt install Ccrypt. So let's say sudo apt install Ccrypt. And it's going to ask for my password. Oh, that was my password. That's good. Okay, so now I can use Ccrypt. And I'm going to use Ccrypt against plain.text.cpt. Oh, I got to have an encryption key. It asked me for an encryption key, right? So I'm down here. Okay, so it says the encryption key is the last name of the person that developed the software used to encrypt the file. Okay, so I got to do some more Googling. So I need to Google who created. Oh, that's interesting. Who created Wi-Fi? Hedy Lamarr. Not sure if that's correct. Who created Ccrypt software? Hedy Lamarr did something, but it wasn't Wi-Fi. Peter Selinger, Ccrypt. Ccrypt is a tool for encrypting and decrypting files and streams, yada, yada, yada. And it gives a person's name, Peter Selinger. Peter Selinger, 1L, Selinger. Saying it over and over so I don't spell it wrong. Selinger. You notice when Linux asks you for a password for something, it doesn't, when you type it in, it doesn't show you the thing. Okay, I guess I typed it wrong the first time. Okay, so now ls plain text.cpt. Oh, you know what I did here? I did the wrong thing. I encrypted it. I didn't I didn't look at the man page. I just encrypted my encrypted thing. The default mode is the encrypt mode. Okay, so I erred. I made a mistake. So let's do this. Let's so what I should have done was I should have used the -D flag. So now I need to decrypt this twice, or I could just download the file again. Maybe I'll just download the file again. That'll be easier. Okay, so my directory is empty again. I'm going to download the file. And now I have plain.txt.cpt. Now I'm going to use Ccrypt, and I'm going to use it on that file. I got to use the -D flag, -D. And now it's going to say enter the decryption key. And I know it's Selinger, Selinger, capital S. Now I have plain.text, and I can cat plain.text, and there's my flag. So I'm going to copy that, go back to my desktop, paste that in, submit, And there's my answer. 25 points. All right, I went over time. Apologize for that. I'll take any quick questions anybody has. Oh, here's my chat. Thanks to the CTF. Okay. Any quick questions? All right, wonderful. Well, this is going to get posted to our YouTube channel soon. And let me go back to my slides because I'm going to refer to some resources. So these will be on the YouTube channel. You can take a screenshot of this. And I'm going to point to some stuff that we shared before. This is a bunch of information about our knowledge base and YouTube channel videos and et cetera. So you can take a screenshot here and have all the info you need. I'll leave this slide up for a few seconds, but with that, I will I'll close and say thanks for being here, or thanks for watching the recording, and we'll see you all next week.